we're going to be making a slightly silly soundboard with Blinky Bits. And it's powered by a 9-volt battery and has a speaker output. And this little board right here is the DY-SV17F. It's a module, it's an MP3 player with 4 megabytes on board, and it can let you store up to 256 different sound files. We're going to put it onto a board here. We're going to do a little power supply right in here with a 7805 linear regulator. And so you can turn that on. And when it's turned on, you can press one of these buttons and play your sound file.
Asking questions, very good way to find out about things.
And you can see that the numbers here are all set up in binary. So if I wanted sound number 5, I press the two of them together.
I'm sorry, Dave. I'm afraid I can't do that.
And occasionally it volunteers 1 or 2 sounds for you. So what we did last day was we started by taking a look at this circuit right here. This is something called the Color Organ Triple Deluxe. It's published on Instructables by a fellow named LED Artist, appropriately named, I think. And I've just modified it a little bit in the diagrams that we're using so that it works off of a 5-volt supply. So I've basically put the LEDs in parallel instead of in series and dropped some of the resistor values down a bit. It's going to be getting its sound output from the DACL line, the digital audio line for the left channel, coming off of the SV17. And that's going to come through here, and that's going to light all that up, all while the amplified signal is playing out on the speaker right here. In order to make this board, we're going to start off by doing the color organ part. Then we're going to do the power supply part right over here and integrate those two together. We only want to route a little bit at a time, because if you try to route the whole board at once, it can get pretty complex. And now what I'm going to talk to you about is making a speaker part so that you can have the symbol for a speaker and the and just a 2-pin output for it. And then we're going to take a look at how to make the part for the SV17 so that you've got the pins in the right place and the right terms on each of the tabs. Okay, so
Yeah, baby.
let's get to it.
So after that little introduction, here's the handout that I have for my students. And so I've got a copy of the modified schematic right on there and a list of parts that I used and the various Fusion libraries that I used for that. So if you want a copy of the handout, drop me a note in the comments or something like that, and I'll send it along. And basically our first part was to design this board. And when you're designing this board, don't try and do it all at once. Like create this part of the schematic, or create this part of the schematic, like maybe right up to here, and then go and route a little bit at a time. Then do this part right in here and route that, do this part and go and route that, and then wrap it all up at the end. Try to keep your LEDs into some kind of neat arrangement that's going to look good on the final project, okay? So that's the first part of the board. Then you're going to come along and you're going to add a 5-volt power supply for it. And basically what's going to happen right here is your battery in right here is going to be a 9-volt battery. It's going to come through a switch right here. Okay, you notice that when I was showing you the video at the beginning, I mounted that switch right on the edge of the board. This pattern for the switch, you could actually just solder a couple wires in and mount a switch somewhere else if you wanted. You'll also notice that I had a couple of extra holes that I put on the board so that I could strain relief the wire coming off the battery. 90% of your success in having electronics projects that last is strain relief for your wired connections. Here we have a 7805 voltage regulator. This is a linear voltage regulator. We're not drawing a lot of current, so we're okay to get away with using a linear regulator. That's going to drop our voltage down to 5 volts on this side. Here's our LED showing that it's on and working. That was a little yellow LED that turned on when I turned on that switch. And here's a capacitor to just help make sure the output voltage from the 7805 stays nice and stable even when we're blinking lights and playing sound. This is going to go to a net called plus 5 volts. So everything in this line, basically from right here at the end of the diode to the output of the 7805 to the top side of R12 and the top side C3, that's all connected to a net called plus 5. And as you recall from routing, the first half of the board, that's going to connect in right over here to these nets that are labeled +5, just as if you'd drawn a wire connecting them all together. Okay, just like all of our grounds right here, those 4 grounds have to be connected to this ground right here so that they can get the power. That's why we put this all together in one schematic, and that's why we're very careful about our naming protocols, and that we double check every now and then to make sure that this net is indeed called GND, and this net right in here is called +5. You might have a different symbol. I think in here I recommended using the DGND. So it's okay if it says DGND if you use the DGND label. Okay, so here's your parts right in here for that schematic. So you can draw that together and then you can route that. And when you route it, double check to make sure that your grounds and your +5 are linked to each other in this schematic and the other one. They're both on the same page, so they should be, but just double check it. And if you double check your circuit board as you continue going through Fusion and developing everything else, you're going to be just fine. This little diode up here is just to prevent reverse voltage across here, but basically prevent you from forcing voltage back this way if for some reason your 5-volt signal goes higher than the value on this side of it. Okay, then what have we got over here? This is what we're going to be focusing on today. We're going to make these 2 parts right here. This is going to be our symbol for the speaker. We're going to create our own custom library component for the speaker and our own custom library component for the SV17F module. And quite often in Fusion, it's easier to create your own part than it is to actually find the thing. And we'll also make sure that DACL pin is connected to a net called DACL, and we'll put a label on it. You'll notice that right up here, when we started doing this circuit, the very first thing that I showed you to do in class most likely was to right click on this line right here after you've drawn the net, right click on it and rename the net to DACL, and then we can apply a label right there so that we can see that that is where the audio is coming in from the DACL line that comes out right over here. So our audio is going to come together and connect to all that. That's also something that you'll check for to make sure that's going through when you do your board. If you've done your schematic right, it will, but we're going to double check for it. And again, there's +5. That's going to have to be hooked into that +5, which is hooked into the other +5s. These switches right here will be the switch momentary part from the Tinkercad library. The Tinkercad library is great, but it doesn't have everything that we want in the format that we want. When you're all done, your schematic's going to look something like this. It's all going to be on one page. You're going to have your power supply part maybe at the top. You're going to have your switches in here, and then you're going to have your color organ triple deluxe coming in right down here. Okay, so today what we're going to take a look at is getting this part right here and getting this part right here, because you're probably getting pretty good at all the rest of the routing. So I've started up Fusion and I've started a new electronics design. Now I'm going to start a new schematic. You're actually going to go back and open up your DY-SV17F audio sound box. I just wanted to show you a few things in a new schematic here. We're really used to coming in here and we're placing a part. We come up here and we pick up the place components. We come over here, we open the library manager. This lets us choose which libraries we want to choose. Last day we had to come in and we had to open up, it says it was capacitor WEMA. Had some nice capacitor symbols that we wanted to use. So we had to come in here and we had to turn that library on. So capacitor WEMA has to be turned on. Aside from that, we're primarily using the default libraries, and we use the Tinkercad library a lot. So you can come down here and you can scroll down until you get to Tinkercad and just double check to make sure that your Tinkercad library is turned on. Where are we? HI Tinkercad. There, make sure that library is turned on. If you see that symbol on there, that just means that we don't have the latest version of the library, and you can go ahead and update it. Generally, I don't do that when I'm in the middle of designing a circuit in case one of my parts changes while I'm in the middle of something. Fusion has ways of handling it, but you don't need that hassle. So wait until you're done in your project and then update things. Okay, so anyway, you've got those two key libraries turned on, but you'll see in my folder, I also have a library that you don't have. And where are we here? It's under J. I have one called Jason's Awesome Library. It might even be Jason's Awesome Library 2 because I've given this presentation before. And you can see I've got some custom parts in here that don't exist in the rest of the Fusion libraries. Okay, I mean, maybe they do, but maybe they didn't have the footprint that I liked. Maybe they didn't have the symbols that I liked. Maybe I was just being fussy. Maybe I was too lazy to go and find them. I just wanted to create my own. So today I'm going to show you how to go about creating your own library and putting some parts in there. Okay, so here we go. You're going to create a new library. And just like we start a new electronics design, you can come up to the top right here and you'll see you've got opening. You can come down here and go, you're going to create a new electronics library. Poof, there's the new library. I'm just going to get this off the screen because that data panel is taking up a lot of space. Okay, and you can see that there's no components in here and there's no selection. And along here, we've got the option to create a new symbol. We've got to create a new footprint, and we can create a new package for the whole thing. And so the symbol is the diagram that shows up in your schematic. So when you create a new symbol, that's what you're gonna see in your schematic. The footprint, that's what's gonna show up on the printed circuit board. When you link the two of them together, you get a component. And if you're feeling particularly fancy, you can create a new package for it, and that's going to show up as a 3D object because yes, this is a 3D CAD program. You can turn your circuit board into a 3D model if you've got all the 3D parts modeled in 3D. That we're not going to focus on so much today. We're just going to do a symbol and a footprint, and then we're going to create a component. Now, before I forget, the first thing that I should mention that you do is let's save the library, okay? Because you'll see it's called Untitled right here. And what we're going to do is we are going to save this library so that we can come to it later on. And you may as well save it into the project that you've been working on. So I've been working in a folder called Winky Blink. Your folder might be called whatever you want. You've got a whole list of your folders in here. You can come and choose your different spaces where you want to put your file, but Winky Blink works for me. And instead of just calling it generic library, well, I guess this is going to become Jason's Awesome Library 3. Okay, and it's going into Winky Blink here. And so let's save that right now so that later on, when we create some parts, they have a place to go. We're going to start out by doing the speaker because that's a fairly nice simple one. And the first thing we're going to do is we're going to create a symbol for it. So click on Create Symbol, and the new symbol name, I'm just going to call this Speaker. Okay, now there are speakers in other libraries and, you know, they're fine. I've got no gripe against them. They just don't look the way that I want. They don't go to 2 pins, and we may as well do an easy one before we go and do the chip. Okay, so we're creating the symbol right here. Now, the symbol is going to have 2 pins on it, okay? And the pins are basically where we connect. So if you're doing a transistor, you'd have 3 pins, okay? If you're doing a 555 timer, it's an 8-pin IC, you'd have 8 pins. We've got 2 pins, so we're going to click on here and we're going to place these pins right down here. And that little round dot is where things are going to connect. So somewhere near the center right there, maybe put 1 right there, 1 right there, pin 1 and pin 2. And we've only got 2 pins. So now you can click on done. Now you've got all your options for rotating them. You can play with the length of the pins on there, but this is all we need for right here. And what we're going to do right now is we're just going to draw a line right in here and make it look kind of nice. Basically, we're just using that. Hit escape if you've drawn all the lines you want. We're going to use that to draw a speaker line. Now, you'll notice I come out here and I'm not getting a nice 45-degree angle. Okay, you can just click right up here and then, give yourself a bit of symmetry in there. Oh, what a beautiful speaker. Click done. Okay, pretty generic speaker symbol right on here. If you want to get fussy, you can put pluses and minuses in there to indicate that. I'm not going to get too worried about that right now. So let's hit save. Wasn't so hard, was it? Okay, so we've got a speaker in here. Now we want to create a footprint for it. And so what we're going to do is we're going to come up here and we are going to go add footprint. And the new footprint being, I'm just going to say speaker 2 pin SIP. SIP meaning single inline package, and 2 pin meaning that it's just 2 pins right there. We want 2 pins spaced 2.54 millimeters, 100 thousandths of an inch apart, typical breadboard spacing. Okay. And here we've got this. Now you recall we had 2 pins before. You don't want the SMD pads, you want a PTH, a plated through hole pad. Okay, so pick a plated through hole pad, come down here and click right there. Now notice your spacing, okay? When you move this back and forth, watch right up here in this part of the screen over here and you can see your spacing. And I guess I'll do 1 right here. And that was at plus 50 mil. And I come down here and I'm at minus 50 mil. So those now are 100 thousandths of an inch apart from each other. Okay. And I'm done creating holes. You'll notice I had a few different options on here. I'm going to come back and play with this. I'm just going to click done for right now. Okay, I can come back and I can click on this and I can go properties, and the shape says square. I'm going to make it a long shape. Okay, oh, that should have changed for me. Come on, make it long. Oh, helps if I click apply. Okay, so click on the, click OK right on here, click on properties. Okay, and make it long, and then click apply. Now you can also play with the drill diameter a little bit if you need to make it a slightly larger hole. I just paused to do a little bit of math because I know that we want to use a 0.9 millimeter drill bit, and 23 mil, that's only going to be a 0.6 millimeter drill bit. We want to go up to like about 35.4 or something for our drill bit. And you can see that hole got a little bit bigger. Our pad got a little bit bigger in comparison. And you can do that. So let's apply that. Let's go OK, and let's come back up here and properties. Let's make that into a little bigger hole as well. That's going to be like 35. Okay, and that's important because you can see it increase the size of the pad. So you can use the 0.9 millimeter drill bit and you can drill through there, and you can do that without ripping up all your copper. If you use the larger drill bit on the smaller size, this pad might not be quite big enough. Now, in fact, since we're making this for students, we can also come in here and say properties. We can assume they're going to have a little bit of error, and you can see the diameter is auto right now. We can take that diameter up and you can play with that a little bit. And let's just try 16. Oh, 16 mil is way too small. We want to take that up bigger. Let's try 66 mil. Okay, and we can make that a little bit bigger. That's almost getting a little too close to fitting right there. Let's try the next size down. That's about where we were before, I guess. It's not much different. We could have left it auto, but you can watch in here and you can play with those sizes. And you know, that 66 on there, that just gives you a bit more meat in case you've got a problem with your etching or somebody drills a little too carelessly. And anyway, we'll apply that. We'll say, okay, what does it look like if we take this one up to 66 as well. That's pretty good. I think our students could solder that without having a solder jump. That would probably save us a little bit of a hassle in the etching process as well. So your choice, you could go with auto, you could go with a slightly larger diameter on here. I like the fact that you've got a little bit of extra meat on here on these pads so that if there is a problem with the drilling, you do have something left to solder to. Anyway, we've got two pads in here, pad 1 and pad 2, and you'll remember we had pin 1 and pin 2, so let's save this. Okay, and now we've got a symbol and we've got a pad. They've each got a symbol and a footprint. They've each got two pins and two pads. So now we're going to link them together. Okay, so we've come in here. We've created the footprint. We've created the speaker symbol. Now we need to create a component to join them all together. So to do that, you come up here and create new component. And we're going to give it a name. And I'm just going to call this speaker. Okay, now we have a speaker component coming in right here. And why is my window all messed up like this? If your window's messed up like that, drag it over here so you've got a little bit more shared space on your screen. Okay, in here, the first thing we're going to do is we're going to click on the Add button, and that's going to add a symbol for us. Okay, and we've only got one symbol, so it better be the one that we want. Just click OK, and that comes in, and we can put it in right here. Now, get it centered. This is what it's going to pivot about. I think we chose that point as our starting point. So anyway, there we go. It's sitting in there right now, and you can see it's got two pins. Okay, click. Done. Now there's a bunch of other stuff going on here for designing more complex chips and all that. We don't need that today. Just click Done. Okay, then come down here and go New, and you're going to add a local package because we created a package and your library only has one package in it. So again, it's going to be a pretty easy choice. And you'll see it says variant name. You know, sometimes when you go to a device in a library and you can click on it and it has multiple footprints. Okay, we could create a whole bunch of different footprints. Maybe we want these with pads spaced further apart. Okay, two pads. 100. Wow. Okay. Where'd my mouse go? There we go. So click OK. And now we've got this right in here. So we're looking at two pins here, two pads right here. And guess what we're going to do? We're going to connect them together using the connect button down here. And we're not too worried whether we get pin 1 to pin 2 or pin 2 to pin 1, but let's do. We've got this highlighted right here and this highlighted right there. Click on connect, and that leaves us with two pins. Click on connect and click OK. We have now connected the pin right here to the pad right there. And that's about all there is for it. We can add a new prefix for it. Okay, we'll call that SPK. Okay, short for speaker. And what we can do is we can save this. Okay, so now in your library, you have a speaker part. And we can come back and edit it later on. But let's see if it works. Okay, you've got a schematic that's coming together over here. Oh, this is, there we go. This is our electronic schematic file. Come in here. And so you might have to go to your library manager now. Okay, and you're going to be looking for your local library. To make it a bit faster to find this is saved in your Fusion Hub. That's your space on the web. So if you click the Fusion Hub icon, you can see I have Jason's Awesome Library 2, and here's Jason's Awesome Library 3. It's got some things in it. And if I want to see what's going on, anyway, use this library is turned on, so I can get in there and I can use that library. That's all looking good. I'm just going to turn that off so it's not limiting me to my selections right there. And you can see it's right in there. Your library is right up there with all the big kid libraries out there. Well done. So now that you're in there, you can come over here to find your part and scroll down to the ones that you're looking for. QR, where's a J? There you go. So find your name in there. Mine's in Jason's Awesome Library 3, and drag your speaker onto the board. You can rotate it around. You can put it where you want. You can put multiple ones on there. Okay. We only need one speaker, but right now we're just testing it to make sure it works. And then what we want to do to make sure that it works is like join two pins together from one to the other one right there. We wouldn't necessarily do that, but let's just click done. And now if you go switch to a PCB document, you should see those show up down here. And you can take them and you can move them around. And so that's just where you're going to put two holes to put your speaker onto your printed circuit board. Okay, so that part's in there. That's looking really nice. And you can see that they're linked together. So we have good net connections happening on there. I'm just going to close that now. I don't need to save that. That all worked out fine. Okay. Same thing with that schematic. I won't be needing to save that. I'm not going to use that again. That was just to test what was going on. However, you'll notice that something that often shows up is the name. Like it'll say SPK2 or SPK1, and that's a really helpful thing for finding your parts. So let's come back to our library, and what we're going to do is we're going to come back to our symbols. And you can always come back and edit this. This is your thing, so you can come in and edit it. So just come in and double click on speaker right there and find your text icon. And down here somewhere, well, tell you what, let's just go. It's got to be the greater than sign and put name on here. Put that somewhere appropriate. And then if you're creating something like a resistor where you also wanted a value, okay. Put that right beneath it in there. I don't know whether you want it there. Yeah, we'll put it right there for now. We'll probably end up turning it off when we're all done. And just hit save on that part right there. Okay, and of course, these are keywords that when you bring that part in, it's going to know about. So let me come back here. Oh, let me also make sure that the library's all been saved. Come back in here, and it won't show up on these ones unless you come in here, and there should be a way to hit update symbol. Name, save, create, swap. There is a way to place it in here. Anyway, I'm just going to delete these for now, and let's try that again. Let's try bringing speaker in again now that we've saved it. And look at there, speaker 1 and speaker 2. Okay, there's your name and your value. We don't need that value for our speaker. We can delete it. We can turn it off. But if you're doing a resistor or something, that's where you'd put in what the value of the resistor is. Okay, so now we've got the speakers and they're labeled and they're numbered. They look good on our board. The footprint looks good. You can add them to your part and good-o. So now it's time to move on to the next step and create the SV17. Okay, so we've got our speaker working and we've got a name and a value attached to it, and that's all looking good. Again, we don't need this file. Let's just get rid of them for right now. We are going to use them in our main file, but right now that was just for testing. What we want to do is, and I had this all queued up, where did it go? Right here. We have a file right. Not that one. The joys of recording on two different screens and having things queued up on the screen that you're recording on. Okay, anyway, here we have a couple of windows, and you might want to open one of these up. you can search for the DY-SV17F so that you've got it open on your second screen when we go through this, or you can take a look at the handout. It's in there. This handout comes down here, and this has the pins and names on it. SPK plus, SPK minus. Now, this is flipped around from the direction that I'm going to be doing it. I'm going to be doing it from the speaker side, having that up in the top left corner. So I'm going to have that board flipped over for reasons that I'll explain a little bit later on. This is looking at it from the top view. We're going to look at it from the other side because that's where the things are printed on mine. And this just goes through how to use it. I buy my boards right here at Universal Solder, although you can also find them at local electronic shops like Lee's Electronics. Anyway, great prices on there. Check it out. And the reason I'm going to do it flipped over on the back is we're going to put our board down so that it comes through with this side facing up. And that lets us do a couple of neat things. One, we can put pins in it and solder it, and then we still see the writing on the back of the board when it comes time to connect to the pins. Or if we want to get really fancy, you can see that these are what we call castellated pads here. And this actually makes this entire board a surface mountable part. And so we'll actually be able to put this on our bottom of our board and solder it directly to the board with no pins and no holes being drilled. If you want to risk it, because if you do it that way, it's really hard to replace it. If you put header strips in and you use pins and you solder in, you can plug it in, plug it out, and you can move it from one board to the next. But if you're really committed and you want to put that on there, just beware that desoldering it to fix it can be a bit of a pain in the butt. So anyway, we're going to design the board this way. So you might want to have a window like that and just carry it off to the other side. That's just Google Universal Solder and SV17F and you should be good. Okay, I think it's also in the handout. All right, so we knew a little bit about making a part now. Okay, we went through in here, we did this. We're going to repeat the exact same procedure. So we're going to come in here and we are going to create a symbol right in here. And we are going to click on the new symbol button. And the symbol for this will be DY-SV17F. Okay, so new symbol name, DY-SV17F. And if you want, you could add more detail. Okay, MP3 player. Just so if you ever forget what that is. Okay, now the symbol for that is going to be fairly simple. Actually, it's just going to be a box. We could get fancier, but it's going to be a box. And it's going to have, let me just count how many pins are on this thing. There's 3, 6, 9, there's 18 pins. So we're going to come down right here and we're going to go pin. And I'm going to start off over on the side, right about here. And every 2 spaces, there's 3 pins. That should be 9 pins right up and down that side. Now I want to put some over on this side of the circuit. Okay, I right-clicked twice and that rotated around. You could have just clicked rotate right there. I'm going to leave myself a little bit of space for the rest of the circuit to show up on there. Maybe one more space. This exact spacing doesn't matter. Just don't go too ridiculously big. And I'm going to keep my numbering coming up. Right up that side. And there we go. When I've got 18 pins in there, I'll know that I'm done. And they're numbered right on there. Now, what we're actually going to do right now is rather than just leaving them numbered, we can change their name. So just come and highlight over top of this first one. Okay, and if you go properties or name, either one brings that up. I'm going to change that name from the very generic pin 1 to say that is SPK positive. Okay, and the next one is properties, and that will be SPK. Oh, I did it properties. So I can change that in here. Either way works. SPK negative. Okay, and we're going to go through here and we're going to update the names on all of them using either changing the name thing, and we're going to match them to what we see on the board itself. So back in a second. So there we go. The pause function saved you from all the excitement of watching me go through there and do them one at a time. Just a couple of things to note as we were doing it. You'll notice that we have an RX and a TX, just like you do on your Arduino. That's because one of the modes that you can hook this up is in serial mode, and you can actually have your microcontroller tell this board what MP3 file to play, which is kind of a cool thing. Okay, let's see. The next thing that we're going to do is we are just going to take our line. We're going to draw a box around it right here and just box that off. Right, like so. Okay, click on done right here. And then usually we want to indicate pin 1 or a corner marker somewhere on here so that we know we're at pin 1. And a couple of ways to do that. One would be to draw a circle right in the middle right here so you can see, oh, it identified the middle of that line for me. I'm going to put that on. Don't go too big. That big's big enough right there. And I should be able to come in here and modify this piece. Now, I gotta say the properties, the drawing tools in here are not as good as you get and the rest of Fusion. And oh yeah, let me just figure out how to do that again. Oh yeah, I got used to better drawing tools. Don't do the circle thing. Just delete that circle. It's an arc that you want. My bad. Come in here and draw that arc about the size that you want. Make it go to a half circle. Tell it you're done. Then move it around here and right click and you can rotate it and put it into position. And if you need to fine adjust it again, the Alt key lets you tweak it in there nice and into the middle. Lets you use the fine adjust. So that just gives us a direction on the chip. That doesn't exactly exist on this board, but just thinking ahead to previous chips that you or following chips you might model. If you need to indicate pin 1 will always just be off to the left right there. Anyway, there's our board right there. We've got 18 pins. They've all got names on them now, and I'm just going to hit save. Oh, what did I almost forget? Text. Right down here, I am going to put the greater than sign and name in here because that'll say like IC1 or IC2 or whatever. And now I'll click done and now I'll click save. Okay, there we go. We have a symbol. Time to create a footprint. Wants to know what we're going to call it, and this is going to be a custom footprint, so we'll just call it DY-SV17F board. Okay, so here's the board for the DY-17F. Okay, so we're going to do this pretty much the same way that we did before. We're just going to add some pads on here. Okay, you know, you can do a pattern. There's you can insert a PTH pad array, but we're just going to do it one at a time. We've only got 18 pins. If you're doing something more complex or you want that 3D package, instead of doing the command to create a footprint, you could come in here and create a package, and there's some macros to help you out with that. That's a good way to do it. Actually, I've used that quite a bit, but we're just going to do it the same way that we did before. We're going to create a pad, and we're going to create them in the same sequence that we did before. Now, remember last time we said we wanted to take it up to like 35 mils, 0.9 millimeters on there. And then we created a little bit bigger solder pad on here somewhere. We went up to the 66 size, and you see that applied. We can edit it afterwards, or we can do it before. Kind of your choice. It is up to you. Now, what I like to do is I like to mark my first pin by making it kind of unique, a different shape. We can add some dots and measurements in here later on. Now, what's going to be really important is that we get our spacing right here, because that's one of the things that working in the computer lets you do that you can't do otherwise. So it's a really good idea to have a reading off of your board on exactly how big it is. So let's see, we're going to need to have about 4 of these above here. So if we just start that with our center, we come down here, we come up 2 spaces, that'll be 1 pin. So that'll be like 2 pins, 3 pins. Here's 4 pins right here. So I'm going to put my first pin right here. Now for my next one, I'm going to go back to using these bigger pads right here with the bigger spacing and the bigger drill bit. So that second pad is going to be 2 spaces down from there, 2 spaces down from there. There's pin 4, 5, 6, 7, 8, 9. Now, the width that you need to come over, you have to come over 800 thou on here. Okay, now I got that by using my calipers to measure the spacing between the holes on my SV17. But really what you can do is you can just hold it over top of a breadboard, because the holes on your breadboard are spaced 100 thou apart, and almost all of our electronics components are designed to match up with that. Okay, so if I want to come over 800 thou, you can see if you look just a little bit above it right up here. When I'm right here, I'm at minus 400 in the Y. So if I come over here, or sorry, in the X, I'm coming over in the X, I'm at minus 300. So if I want to come over 800, I should be at plus 500 right here when I come back up. And, oh, that's not where I want it. Okay, just Control Z that. BDH pad, 1, 2. Really important that you get your footprint right when you put this together. Okay, so there's my 18 pins. I'm done right there. And that's looking pretty good. Okay. Now you can add a few other things in here if you want. This is all coming in on this layer. We can add a line to it to add a little bit of, diagram right in here. So if you want to put a line around here, you'll notice that the line should come just outside of that. Comes right around here. And the line's a different color. That means it's coming in on a different layer. Okay. And just like with the other board, you can come in here and you can put some text in here. And the text I'm going to put on here is name. So that can apply and go right in there. You can put DYSV17, because this is just going to be documentation. It's not actually showing up on the copper layer. Okay, and just so people match it up the right way around, we did put a different pad in there for pin 1 so that we know the orientation and we know which way it goes. But you can also come in here and under draw, we did that arc before, and we went 1, 2, dialed it back to that point right there. We said done. We can take that now, and right clicking rotates it around, and that sits right in the middle right there. So now when we're looking at our board, we know which way around that board should be going, so that our pin 1, which is going to be SPK plus, is going to be right up there. Okay, and there is what our board looks like. Now again, this is what our board looks like looking down on it from the top with SPK plus in that corner. I think I've got everything in there that I need. And so let's hit save. Okay, Well, we've got a symbol, we've got a footprint. Let's go ahead and create a component, and we're going to call this component the DY-SV17F MP3 board. Okay, there it is right there. And we are going to add a new symbol in right here. Oh, sorry, cancel. We're not adding a new symbol. We're coming to here and we're adding a symbol to the component. It's that symbol right there. And you can see we can choose speaker or we can choose DYSV17F. And there's our symbol, and we can put it right over top of the icon in the middle. And now we've got a component that we can hook up on there. Okay, then over on this side, we'll just click done. We'll go new, add local package, and there's our DYSV17F, and we'll say okay, and it appears right in here. And now we're going to connect the pins, and now this has all been sorted alphabetically rather than pin number. So we're going to have to be really careful about what we do right here. Okay, so pin 1 is right up here. You can see that's right up there, and that is going to be SPK plus. So here you need to come down this side, and SPK plus maps to P1. You click OK, okay, and click connect. Sorry, SPK plus. SPK plus goes to P1. You click connect. You don't click OK just yet. Okay, that links those two together. Then you can also come along here and say, well, pin 2, okay, looking at your board, that's going to connect to SPK minus. Connect. Okay, and watch this as it's coming together. We've got SPK plus on pin 1, SPK minus on pin 2. You can compare that to the picture of the board. Make sure that you're getting this right as we go along. DACL will connect to pin 3, and DACR will connect to pin 4. Those two worked out nicely. On pin 5, we'll have plus 3.3 volts. You'll see they call it V33. I think this makes a little more sense. Okay, pin 5 is plus 3.3 volts, and pin 6 is going to be 5 volts. Okay, on pin 7, you're going to have con 3/busy. On pin 8, you've got con 2. On pin 9, you've got con 1. On pin 10, now keep in mind that we're going counterclockwise around the board, looking at it from the top. You're going to have GND on pin 10. And after that, you come to IO7 on pin 11, IO6 on pin 12, IO5 on pin 13, IO4 on pin 14, IO3, pin 15, IO2 on 16, IO1 on pin 17. That is also our RX pin, and TX is better be our final one. So there is our whole list right there. Drag that window a little bit bigger and double check your list to make sure that it looks like my list right here. This has it listed this way. We could also sort by the pad number. So if it's easier to sort by the pad number and go speaker plus, speaker minus, DACL, DACR, 3 volts, 5 volts, con 3 busy, con 2, con 1, ground, IO7 all the way through down there. Make sure you've got that right, and those should be the correct connections. You've just created a custom chip. Hit save. Okay, that's all good. Let's come back over here and let's try that in our practice schematic right in here. Okay. Why is that not showing? Oh, because I didn't save the library. Still saving. It's up in the cloud there. Okay, it is saved now. I should be able to come over here. I've got that part in the library right there. Should be able to come in here, and my library is not updated just yet because there was a save on there. Try going to a different library, coming back to this library, and there you go. So you switched from one library to the next so that this one has an excuse to update, and add your board right in here. And look at that, there is your custom board. Okay, we're going to click done. Let's bring in a speaker. Okay, and let's take that speaker and connect these together with a net. Okay, and then try one or two other devices in here. Just come in and out of, say, go to your Tinkercad library, find some different components in here. Went past it, went too fast. Went past it the other way. Come on, where's Tinkercad? I could just type in and search for it. THILTINK. Oh, sorry, I'm looking in the wrong. It's getting late. Up here, I want to come into this library. This is where I'm looking for my libraries. What am I doing? QRST. That was all my parts down below. I was looking for parts. There's Tinkercad. Pull up Tinkercad, grab some parts from the Tinkercad library. 555 timers. Let's bring in, I don't know, a resistor. Okay, R doesn't really filter it down. Resistor, yay. Took incredibly long time. And let's add a resistor here and a resistor there. Let's just make sure this is going to work out so that when we draw those lines in there. Okay, let's switch that over to a board right now. We're in the schematic right here. Switch to a PCB document. Hey, look at that. There's your footprint in right there. Drag that on here and check to make sure where those air wires are routed. That one's connected to the bottom one. Yeah, that looks right. That looks right. It's in there. And you've got a speaker connected to those two outputs. This is looking like it's going to work out okay for you. You've got a part that you can connect to. Remember not to put things in there. There's tricks and all that you can do that you might be able to do that, but don't. Okay, so there you go. You've got two custom parts in your library. We're not going to use them from this diagram, okay, because we're just going to close that off. I don't need to save that. That was just for testing. Don't save that. Jason's awesome library. Yeah, heck, make sure that's saved. You just spent 53 minutes and 40 seconds of your life listening to me talk about that and try to find the right button to push. But if it's saved, you can close that off right here. There was another example where I was playing around with things. Let's close that off. You don't need to save that. Okay, I don't want a new electronics design. What I want to do is I want to come back over here and show my data. And I was designing the Color Organ Triple Deluxe. Open that electronics project. And you can see that I've got one schematic in here. Hopefully you've gone through and routed all this first. Like I say, route this earlier. It's easier than coming in and adding more stuff. Okay. So on the Color Organ Triple Deluxe board, I can come in here right now and I can come in here. I can find the Jason's Awesome library, wherever that's gone now. BQLNOP, where's Jason's Awesome Library. I put into Jason's Awesome Library 3. Okay, I'm not looking for resistor, just hit delete if you were still searching for something. And if I need a speaker, I can drag it in here, can put it in like that. And I need an SV17 soundboard, can drag it in here, can put it like that, can click done. Now I can come in here and I can start linking these together. Okay, now your +5 line right here, you can take that +5 and to make sure it stays as the same line, right click on there and copy it. And now you can come up here and when you're going to connect that in here, you can click right there, you can say done. And now connect this net. And if you bring that into +5, make sure it connects there. Okay, and then if you find one of your grounds down here, yours might be DGND. Okay, always, if you want, check the name of that net. See how the name of the net is GND? Click OK. That's a sign that everything's working okay. Let's just copy that one. And we can bring that up there. There's your GND right there. And now you can connect that in there. And if we right click here and we go properties, you can see the name of that net became GND, which is really nice because that means that's the same name as the GND down here. And that means those two on your board are going to be connected. So if you come over to your PCB right here now, oh, look at that. We've got an SV17F on our board. And if you follow those lines, they should be connected to a ground pin somewhere. You should see the air wire on here. Okay, maybe it doesn't want to talk to that because it's not on the board right now. Let's bring that over here. There's your speaker down there. We didn't hook that up to anything. And you should be able to come in here and take a look at that pad right there. And if you zoom in, there's the GND that it's connected to right there. Move that around. So there's your GND. It's coming over here. And if you zoom in on that, it says pin 10 is assigned to the net ground. Okay, so everything's working good. Pin 6 is assigned to the net +5V. Zoom in right there. That says +5V. It comes through all of these ones here. It comes up in there. It's connected to +5V. And that +5V, where does it go? It goes to the next +5V over there. So those air wires can be a little bit confusing, which is why I recommend you route little bits at a time. Clearly, I haven't done on this on board because I did it on a different board. Hey, if I click stop now, this is less than an hour. And if you've watched it at 150% speed, it's not even that long. So thank you for sticking with me. That's the final part of creating the overall schematic for your board. Comes out looking something like that. Or if I look at it in Fusion 360, where's my MP3 sound box? Here's my overall schematic right here. There's my board. There's my speaker. Again, you'll remember that when we connected this, all we had to do was we just drew a little line coming out of here. And so I'll show you how to do it with DACR because I've already done DACL. Just draw a line coming out of your pin. It only has to go that far. Click done. That creates a new net. Right click on it to get your properties. The name of that net came out to be N27. But we're going to rename it to DACR because that's the digital audio write pin. Okay, and then you can come over here and you can pick the label button, click right on there, and I want my label to look something like this. And I put it right in there. Doesn't that look pro? That's awesome. And then anywhere else on my board, say I wanted to do a second set of blinkies like this, I could just copy all of this and change that to say it's connected to DACR. That label would change and I'd have two sets of color organs and they'd all be connected to the same nets and you'd have this beautiful modular thing going on. There we go, 1 hour. I'm done. Have a lovely afternoon.